I decided to make a self-flying quadcopter for my project. As an overview of what I'm going to be talking about, I'm going to be talking about the problem, the research that I did, the considerations made, the budget that I had, the process of prototyping, problems and failures, my final solution, and the lessons I learned throughout the process. So the problem is, how would I be able to make a self-flying quadcopter that can all take off, fly, and land all by itself, with the only human interaction being turning the thing on? So there's a lot of questions and stuff I had to research. First I had to figure out how a quadcopter was built. There's two different types of frames, for example. There's the X frame, which I did, and an H frame, which would be in the shape of an H instead. So I also need to know how to code a ping sensor, a digital potentiometer, an accelerometer, and some other stuff that is just minor stuff. But for example, various Arduino coding functions. And I had to also know how much tolerance to give to the models when trying to get a nice tight fit for 3D printing. And I also had to figure out how to design a chassis to allow for maximum functionality and minimum weight. So, considerations I made. How much weight can you put on the quadcopter? I had to figure out the lift of each motor, which conveniently they put on their website. But I had to find the lift of each motor, and then my entire quadcopter has to be lighter than the amount of lift that the motors can provide. So I also had to figure out how much the parts would cost because of the budget that we had. I had to also figure out how to design the chassis. I already said that. I had to figure out if I could finish it in the 2 weeks, which I didn't end up finishing it, but it'll definitely eventually get done. I have to also figure out how to make the quadcopter take off and land, because once it's in the air, it can figure out what it's supposed to do, but I've had to figure out a way of how to speed up all the motors and slow them down together. Then I had to make the quadcopter know what's around it, which is what this is for, which I'll show after. But it basically allows the quadcopter to understand what's around it, so it doesn't crash into anything. It's going to make adjustments depending on that. And yeah, so that's why I said the quadcopter will make a decision that which way is best to turn depending on the signal it gets from that. So I got cut off. Anyways, that's my list of things for my budget. So for the process, we first just started by designing the basic idea of what it's going to look like. And then I went a bit more into detail trying to figure out how I'm going to, for example, figure out the motor holders, which are over there. I had 3 separate designs, and I kind of didn't end up using any of them at the end, but it's still a process. And this was my original list of stuff that I was going to get, and I'll be honest, it changed a whole lot. I pretty much, maybe only half the things that are actually on this list I actually ended up using at the end. Yeah. So this is what I use to figure out how the quadcopter is going to turn. If you consider it, when I want it to turn right, you have to slow down the right motors and speed up the left motors, but the back motors still have to be faster than the front motor so it still goes forward. So that's what all these are for. So this was my original design of the chassis on paper, and then this is the model in SketchUp. And then that's the model at the end. So you can see how it is slightly different than the original, but it still ended up having the same idea. And I have to obviously make all the measurements on paper first, and then transfer all the measurements into SketchUp. So this is again just a little bit more planning with all the measurements, and how I plan to use a little LED to indicate what the quadcopter is actually doing. Otherwise, there's really no way of figuring out what it plans to do next. This is a very, very basic wiring diagram, but essentially that's the Arduino over there, which is the thing I use to program it. And you have to connect all these pins to the pins of this thing called digital potentiometer, and that connects to the motors. And there's a lot of other little things here and there, which I'm not going to go into detail about. And there's also an accelerometer, so if it gets slightly off tilt, the Arduino can get back onto track. many, many fold space. So, as for the motors, I ordered the wrong motors, the wrong props. I ended up having to order a new motor like 3 times, and a new set of props. And when we did order it, only one motor ended up coming. There was probably an issue with the shipping, but it was okay because we ended up buying some more from Radio Shack. And so the motors weren't really fast enough, so we're probably going to end up ordering different ones. So as for the printing, a 3D printer works by printing from the bottom layer to the top layer. So if there is something on the top layer that's like hanging off, then it's just going to fall off when you try to print it. So you have to make something called a support, which becomes an issue with trying to peel it off and an issue with trying to format it onto the build plate. So you have to keep that in mind when designing things that are going to be printed. So as for the shipping, because we only had a 2-week period, we had to figure out like whether it'll ship in time or not. And if it did not ship, then we had to find something that would probably work. There's a problem with 3D printing. It's called warping, which means that the corners of your build are going to fold up, and it ends up being very, very like a really big problem when you're trying to get a nice tight fit. The image has, you can't really tell. It's kind of hard to see in this image, but the edges are curling up off the plate because the bottom layer cools before the next hot layer comes onto it. So we had to get wooden dowels for the to connect the chassis to the motor holder, and these are those dowels. So this is what I was talking about before with tolerance. I didn't consider adding a little bit more room in the holes for the chassis here. I can actually take this off. Yeah, I have to actually design this hole over here, and I have to put exact measurements in. You can see over here, I ended up sanding down the wood a little bit because it didn't fit. So I should have added a bit more tolerance to that, and that's one of the problems that I had. As for the coding, I didn't know how to code like anything, but I got a lot of help from Daniel, thanks. He helped me a lot with the coding. So I learned how to code digital potentiometer, accelerometer, ping sensors, and now I learned how to code ESCs, which it's very, very difficult. But once you get the coding down, you have to do troubleshooting, but we'll get to that after. And I also searched online to get some examples for the code, and then you can just copy it and use it for your own purposes. So I did have to consider the weight. If the chassis was too heavy, then the quadcopter could not lift off the ground, but if it was too light, then I probably don't have enough batteries or something in it, so it just wouldn't have enough power to take off. So I have to have a really good balance between the two. So I ended up changing the chassis design. This is the original chassis, which you can see on here right now. You can see how big it is. It's, I don't know, a couple inches, but this is my new chassis. You can probably guess how much smaller it is, but you can't really see the ruler here, but it's a 7 inches. It's about 7 inches long, and then the new chassis, it's about 1 inch long. I really made like a huge change here to try to get this thing off the ground. It still didn't end up working, so we're going to redesign it again and use more powerful motors this time. And that's just a comparison between the two. I also used a smaller Arduino. So this is the Arduino Uno, which was actually like the second thing I was going to use. There's an Arduino Mega, which I ordered, which is about this big. But you can see I ended up using the smallest, the screen board right here, which is the Arduino Teensy, which is just 1 inch long. It's a very, very small and light board. And if you were curious, the board itself is lighter than paper. So it's a really, really small board, just weighing at 2.4 grams. So troubleshooting. I had some issues lifting off the ground. So the motors weren't fast enough. They didn't have fast enough RPM to get off the ground. So I had to get motors that had a faster RPM, which is rotations per minute. And I I'm really bad at explaining code, but basically, if there's this thing called a variable in code, and if you put the variable below when you call it, it doesn't end up working, and you get a bunch of errors. And yeah, you know what I'm talking about. It's not fun. It's a big mess with the coding, but so you have to get everything in the correct order. Otherwise, it just won't run. It's gonna give you a big error, and then you have to go back and troubleshoot all of that. So what could have been done better in the planning? I ended up going from an Arduino Mega to an Arduino Uno to a Teensy, which is a huge difference. But if from the beginning I knew what I was gonna probably end up doing at the end, I would not have gone for that approach. So this thing on here, this little guy right there, that's called a ping sensor, and that essentially sends out a very, very high-pitched sound and calculates how long it takes for the sound to come back, and that's how it knows how far away something is. I was going to use 5 of those, but rather than that, I ended up only using 1 ping sensor and 1 servo. A servo is kind of like a little motor type thing. It ended up blowing my budget because of the Arduino Mega, which is really expensive, but I could have avoided all this by just ordering like the right motors the first time and not having to reorder over and over. So as for the research, I could have learned how ESCs work in the beginning and gotten those motors from the beginning, because I ended up going through I think 4 pairs of motors, or yeah, I mean it was a lot of motors. Because quadcopter motors are faster and have a higher torque, but they also are a lot lighter for what they're able to produce. So what worked well was designing the frame. Though we ended up redesigning it, this frame, for example, we used holes over here for the wires to go through, and we had kind of like these gaps over here, which were for trying to reduce the weight, and it left some room for the batteries. So in conclusion, I learned many things during this process. I learned more Arduino coding. I learned that research was important. I learned that designing will allow for better chances of success, and learned that having a budget is difficult but totally necessary.
What do you want to do with the quadcopter?
No idea. I'm just making it because it seems like a fun project, and I'm probably going to learn a lot out of it. I've already learned so much. So.
How'd you come up with the idea?
I just thought wouldn't it be really cool to have this challenge where you have an Arduino, which is meant for this kind of stuff with robotics, but having to control it entirely. Oftentimes there's someone a person controlling the Arduino. This time it's doing everything by itself. So.
Are you able to hold it up so everyone can kind of see it?
Oh yeah, should I demonstrate it? I'm gonna plug it into a computer.
This one?
Wherever
You can bring your computer over if you need to.
You may want to point out a lot of this is working, so you may want to point out what parts of it you were able that are already working.
Alright, so I'll just show you this thing quickly. Okay, so this right here is the Arduino that I ended up using. It's very, very small. This is a servo, which is like the motor I was talking about, and this is the ping sensor, which I mounted on top of the servo. And when I plug this in, you can kind of see it working. I've had so many issues with this today, I don't even know if it's going to work. Let's see.
What is it supposed to be doing?
Oh, there it goes. Yep. So, well, it's kind of working. See, because it detected me it's basically looking around to try to find any objects. And so basically, if the object was too close, then it would stop for a second and change the speed of the motors. There's no motors on here, so you can't see it. But if it ever pauses, that's why. You see that pause because it detected an object very close to it. So it would have essentially, yeah, then it turns back on. But it'll essentially then change the speed of the motors. And this is my system of how to detect walls and stuff. I didn't see it stopped again. Probably detected something. Yeah, it just keeps going. So.
How much was your actual budget?
200. About. Okay.
So you are going to come back and finish this?
Yes.
Okay. So what do you think overall, beyond just learning how to build